Hi, welcome back to GMMDC NMU YouTube channel. This is another CAPS Mathematics Grade 12 video on the topic trigonometry and specifically on trigonometric functions. Right? It can be used for both grade 11 and grade 12. In this video, we're going to look at trigonometric functions, namely the sine, cosine, and tangent functions. Let's firstly look at the contents of this video. Firstly, I'm going to have a brief overview of properties of trigonometric functions. Then we're going to look at transformations of functions, and specifically related to the trigonometric functions. Then I'm going to show you how to sketch functions using the table mode. And then we're going to have interpretations of graphs of trigonometric functions. And then applications of the above. And then, as usual in all the videos, there's an exercise worksheet. So let's start with the overview of properties of trigonometric functions. Let us start with the sine function and its properties. Let's look at the graph there. First of all, what's important about the sine function, that the sine function has a period of 360 degrees. Right? As we know of the sine function, it's positive in the first quadrant, positive in the second quadrant, negative in the third, and negative in the fourth quadrant. Right? The range of the sine function is between -1 and 1. Right? So in other words, the values, the function values for sine x will be between -1 and 1. Okay. Now we can plot a few points. Sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, sine of 360 is 0. Right? We can also plot a few points, additional points, and if we plot those points, and we can even plot more points there. Right? And if we join those points, we get a curve, and that is the sine curve. Right? The sine function is a periodic function. In other words, it repeats itself every 360 degrees there, right? As you can see, in the first quadrant it's positive, in the second quadrant it's positive, in the third quadrant I get negative values, and in the fourth quadrant I get negative values, right? Now the amplitude of the sine function is 1. As you can see, the coefficient of sine there is 1 there. And this one is, if you look at the distance between the minimum and the maximum, the total distance is 2. So the amplitude is half that distance between the minimum and the maximum. So 1 plus 1 is 2, divided by 2 gives me a amplitude of 1. Now let's look at the cosine function. Let's first of all have our axes there. The period for the cosine function is 360. First quadrant is positive, second quadrant is negative, third quadrant is negative, fourth quadrant is positive. The range for the cosine function again is between -1 and 1. -1 included, +1 included. The minimum value is -1 and the maximum value is +1. Sine of 0 is 1. You can plot a few more points. Sine of 90 is 0. Sine of 180 is -1, sine of 270 is 0, sine of 360 is 1. As you can see, it's positive values in the first, negative in the second and the third, and then positive in the fourth, right? And if we join that curve, that's the cosine curve, right? It's also a periodic function. This pattern is repeated every 360 degrees. So I can go on the positive side, I can also go on the negative, which we will look at later. The amplitude again, the amplitude is the half the distance between the minimum and the maximum. So between -1 and 1, the distance is 2, and half of 2 is 1. Also, you can see from the equation there, cosine x, so that's 1 cosine x, so the amplitude is 1. Now let's look at the tangent function. Again, let's get a graph. The tangent function's period is not 360, the tangent has a period of 180, right? Let's look at this. Positive in the first quadrant and negative in the second. Then positive in the third and negative in the fourth. You can see it repeats, the pattern is repeated every 180 degrees. Positive, negative, positive, negative, positive, negative, right? The range for the tangent function, just note here, is between negative infinity and positive. It doesn't have a minimum, it doesn't have a maximum value. And because of that, it does not have a amplitude. So if I plot a few points in the first quadrant, plot a few points or calculate a few points in the second and in the third and the fourth, and if I join that, that is the curve that I will get, right? Notice tangent of 90. Tangent is undefined for 90, and we refer to that as a asymptote, right? So there are two asymptotes, one at 90 and one at 270, right? You can see between 90 and 270, again it's 180, right? Same period there. Now, let's look at the transformations of trigonometric functions. The type of transformations we're going to look at would be, for sine, will be a sine x, b plus sine x, sine of cx, and sine of x plus d, right? You can see there's a change here, there, and then there's this different change there, and there's a change with the x, and there's a change with the x there. And the same applies to the cosine and the tangent. Now let's look at the different types of transformations there, right? We had the equation. Let's look at the different types of transformations. The first one there is reflection in the x-axis, and that is denoted by negative fx. If my function is fx, then the reflection in the x-axis will be negative fx. Then we have vertical shifts, and vertical shifts are fx plus a, plus a constant. And change in the amplitude, that will be a times fx, right? So the change in the amplitude is a fx, and the vertical shifts are fx plus a. Then we also have to have change in period. The change in period, that will be fax. And then we also have horizontal shifts, and this is fx plus a, right? And we look at, these are the four transformations we're going to look at in a little bit more detail. Now let's start with the reflection in the x-axis, and here we're taking the sine function. So we have fx equal to sine x, and we know the amplitude is 1. Let's look at that sine curve. There we have the sine curve. You can see it's positive in the first and the second, and negative in the third and the fourth. There's a period of 360, and it has an amplitude of 1. Okay. Now if I really want to reflect it in the x-axis, gx is negative sine x, right? So in other words, every output value needs to be multiplied with a negative 1. 0 times negative 1 is still 0. 1 times negative 1, you see, becomes negative 1. 0 times negative 1 stays a 0. Negative 1 times negative 1 becomes a positive 1. 0 times negative 1 becomes, just stays a 0, right? And if I join that, that is what my reflection in the x-axis will be like, right? That is negative sine x. Let's take the other one back so we can compare the two. So if I want to reflect it in the x-axis, sine x becomes negative sine x. Although I have a negative 1 there, the amplitude is still positive 1. Let's consider the cosine function as well. So we take our cosine function, again an amplitude of 1. And now if we want the negative, so each of the points will have to reflect it now. So that positive 1, if I reflect it in the x-axis, there it becomes negative 1. 0 reflected in the x-axis still remains 0. Negative 1 reflected will go to positive 1. 0 reflected remains at 0. Positive 1 becomes negative 1. If we join those points and get the curve, that is what the negative cosine curve looks like, right? Let's bring back the cosine so we can compare the two there. So That's the reflection of the cosine function in the x-axis. Again there, although I have negative cos x, the amplitude still remains a 1, so it's positive 1. Now let's consider the reflection of the tangent function in the x-axis. Let's get our tangent function there. See, we have one period of the tangent function. It's positive in the first and then negative in the second, and a asymptote at 90. For negative tangent, let's try to get the points. 0 reflected remains a 0. 1 reflected becomes a negative 1, right? Negative 1 reflected becomes a positive 1. 0 reflected stays a 0, right? If I join those points, that is what the reflection of the tangent function in the x-axis will look like, right? As you can see, the asymptote has not changed. Let's bring back our tangent function there. There you can compare the two. So if I have negative tangent x, that is what the negative tangent. So if it was positive in the first, it becomes negative in the first, right? If the original one was negative in the second, the reflection becomes positive in the second. Now let's look at the vertical shifts and change of amplitude, and we'll start again with the sine function. So let's look at our basic functions, sine of x and the amplitude of 1. Now if I have 2 sine of x, right? In other words, 2 times 0 will stay as a 0. 2 times 1 will become a 2. 2 times 0 is a 0. 2 times negative 1 will become a negative 2. 2 times 0 is a 0. And if I draw that graph, that is what I will get, right? As you can see, the amplitude now is 2, right? And then so if I have 2 sine, I have a change in the amplitude. The amplitude is 2. So each value there is multiplied by 2. So A here represents the amplitude then. Remember, the amplitude is always a positive value. Now let's look at this one. Let's take the other curve away there. 1 plus sine x. So now let's see. 0 and I add 1 to it. That is what it becomes, right? If I take 1 and I add a 1 to it, it becomes 2. If I take 0 and I add a 1 to it, it becomes 1. Negative 1, add a 1 to it, it becomes 0. 0, add a 1 to it. And if you can see there, if I draw that graph, so you can see this graph there has been shifted 1 unit up. All the points have been shifted 1 unit up vertically, right? So if I have 1 plus sine x, that's a positive 1. So it will be a vertical shift of 1 upwards. Okay, so you can see there in this case, that 1 is a positive number. So it will be a vertical shift of, if it's 2 plus, it will be 2 units up. If it's 3 plus, it will be 3 units up there. Let's bring back the other one so we can compare them. That was the change in the amplitude, right? As you can see, with the sine x and 2 sine x, they start at 0, 0. And the 1 sine x, that point is moved. It's not at the origin anymore. It has moved. But the period of all 3 of these graphs, I have x, x, x. The period is still 360. Next, let us look at the cosine function. Let's start off with the cosine function there. Okay, that's the cosine function. It's for one period. And if I now have negative 2 cosine x, you see negative 2, that means it's a reflection in the x-axis, and there's also a change in the amplitude. So 1 times negative 2 will become negative 2. 0 times negative 2 is 0. Negative 2 times negative 1 becomes positive 2. Negative 2 times 0 stays a 0. That's a 1. 1 times negative 2 will become negative 2. And if we plot those points and draw the graph, that is the graph, right? So we see it's a cosine curve, but it's a reflection of it in the Because of the negative, it's a reflection in the x-axis, and it has a change in amplitude. Let's remove that negative 2 cosine x, and let's look at the negative 1 plus. So here I have the cosine x and a negative 1. So it's negative 1 plus cosine x. So 1 with plus negative 1 will give me a 0, right? 0 plus negative 1 gives me a negative 1, right? And then negative 1 with negative 1 gives me negative 2, you can see there. And then 0 plus negative 1 gives me a negative 1. And 1 plus negative 1 will give me a 0. And if I join those points, that is the graph I get. As you can see there, from the yellow it moved down 1 unit. So everything moved down 1 unit. So if I have a negative there, let's add it to the cosine, then it's a vertical shift down. Okay, so in this case, that negative will indicate a shift down, right? So let's say negative 2, so it will be 2 units down. Negative 7, it will be 7 units down. Let's consider the tangent function. Let's look at the vertical shifts and changes there. So if I take fx equal to tangent x, there's my tangent graph. As you can see there, the period is 180 and it has an asymptote at 90. And tangent does not have a amplitude, right? Remember that tangent does not have an amplitude. So if I want to take gx equal to 2 tan x, that 2 is not an amplitude. So in other words, every output value has to be multiplied by 2. 2 times 0 will be a 0. 2 times 1 becomes a 2. 2 times negative 1 becomes a negative 2. 2 times 0 becomes a 0. And there's my 2 tan x graph. Same asymptote, same period. Right? It's just stretched. And the 0, 0 remains 0, 0. Now let's just remove that one and let's look at the 1 plus tan x. So here, every output value needs to be added by 1. So I take 0 plus 1 gives me 1. 1 plus 1 will give me a 2. Negative 1 plus 1 becomes a 0. 0 plus 1 becomes a 1. And if I join those points, you can see there, you can see the tangent graph has been shifted. Yeah, it's been shifted 1 unit up, right? That point was shifted 1 up, that point, all the points are shifted 1. The asymptote still remains exactly where it is. Okay, so there's no change in asymptote. Let's bring back the other one so we can compare the 3 graphs there. So in this case, the b tan x, the graph is stretched. That is not an asymptote. That's not the amplitude. The asymptote is 90, and you can get more asymptotes by just adding the period to it. If I extend my domain, I can get more asymptotes there. This is just the general solution for the asymptotes. Now let's look at the next transformation, which is change of period. Let's start off with our sine x again, and we notice the period is 360. Right? Let's go and focus on the period. So if I take sine of 2x, there's going to be a change in period. You see the x, that's 2x. So the period there will be 360 divided by 2, and that is 180. Right? If we plot those points, that is what we will get there. Right? And you can see you actually get 2 sine curves between 0 and 360. If I had sine of 3x, I'll have 3 of those sine curves fitting in between 0 and 360. And if I should have half x, I'll have half of the curve fitting in there. So that's the change in period. Let's take sine of half x. See, I'm taking that one away. And this is what the sine of half x will look like. You can see there. There's the full sine curve. And this is half of it. And that is half of the pattern. And you see the period. So when I have sine of x, the period is 360. Sine of 2x, the period is 360 divided by that 2. And when I have sine of half x, it's 360 divided by a half, which is 720. And generally, we can represent it as follows. So if I have sine of AX, there's going to be a period change, and that's going to be 360 divided by that constant value A. Also, let's look at the cosine function as well. There I have the cosine function and also a period of 360. Cosine of 2x, so the period is 180. So in this case, I'll be able to fit, you can see there's one and there's another one, right? And you can see there's the period 180. Then cosine of half x, I'll have half of this. You see, this is the curve there, and this is what half of it will look like. Just that half, there's a half and there's another half. And if I represent that, there's half of the curve, right? So I've only represent half of the curve up to 360. I need another 360 to complete the curve. So the same way here, if I have cosine of AX, then the period is 360 divided by the constant A. Also look at the tangent here. Tangent's period is 180 and it has an asymptote at 90. Let's focus on that. So tangent has a period, and we must also bear in mind the asymptote. You see there's the asymptote. Period of 180 and an asymptote at 90. So if I'm going to have tangent of 0, or half x, it's going to be 180 divided by half, which is 360. And the amplitude, the asymptote also changes, right? That is 90 divided by a half, which is 180. And if I represent that, you see there's it there, right? So you see there was the asymptote at 90, now the asymptote is at 180. And this is what half a tangent, I need another 180 to complete the tangent curve there. So exactly the same, but just remember to work out the period, it's 180 divided by A, because tangent's period is 180. And the asymptotes will now change 90 divided by A. And if I have the general solution, it will be pi over AK, where K is element of the integers. Now let's look at the horizontal shifts. And again, we start with the sine function. There's our sine function. And now we want to have sine of x minus 90, right? Now when I have x minus 90 degrees, the minus indicates it's a shift to the right. So that will be 90 degrees to the right. And if we plot those points, you see this, look at this here. 0 will have to go 90 degrees to the right, right? And the 1 will go 90 degrees to the right. It goes there. And that point will go to the right, ends up there. That point to the right goes there. And that point to the right goes there. You see the whole graph has shifted there. You can see. There's the graph there, so let's put in that graph. There's the graph, right? But we want to just draw the graph from 0 to 360. So you see this part is extra. Let's just remove it. And I can place it there. Okay? And this is from 0 to 360. So if I have a negative angle, then it means you shift it to the right, right? If this negative 70, it will be 70 degrees to the right. Negative 10, it will be 10 degrees to the right. Okay. Now notice also that if I take sine of x minus 90, and if I use my reduction formula here, right? Sine of x minus 90 is equal to negative cosine of x, because x minus 90 is in the fourth quadrant, right? Therefore, sine of x minus 90 is negative cosine of x. Now let's look at the horizontal shifts of the cosine function. Let's start again with our basic function cosine of x for one period. And we want cosine of x plus 90. I'm adding an angle there. And if I add, I'm moving it to the left. So that point, I move it 90 degrees to the left, it ends up there. That point, if I move it 90 degrees to the left, it ends up there. That point 90 degrees to the left, it ends there. That point 90 degrees to the left ends there. That point 90 degrees to the left ends there. If I join that graph, and that's the cosine graph there. You see, we want to draw it from 0 to 360. So let's remove that portion and just put it at the back. Right? There's. So if I have plus an angle, that plus indicates I'm moving it to the left, right? So if I have plus 30, it is 30 degrees to the left. If I have plus 45, it's 45 degrees to the left. Also note, if I take cosine of x plus 90, x plus 90 is in the second quadrant, and cosine is negative in the second quadrant. So this cos x plus 90 using the reduction becomes negative sine of x, right? The co-ratio there. And you can see there that this graph there is the sine function, but the negative sine function. Okay. Now let's consider the tangent function as well. So the tangent function, the period is 180 and the asymptote is at 90, right? So that's a standard tangent function. Now let's look at tangent x minus 45. The period is still 180, but the asymptote now, because if it's subtracting 45, it moves 45 degrees to the right. So in other words, the asymptote 90 degrees will move 45 degrees to the right, and all the points will move. So that point moves 45 degrees to the right. 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 Okay, and if we draw the graph, that is the tangent graph that we have, right? And you can see the asymptote now is not at 90 anymore, but at 135, right? Generally, if I have tangent of x minus an angle, then it shifts, if that's a degrees, it shifts a degrees to the right. Subtraction shifts to the right. The period is still 180 because there's still a x, and the asymptote is 90 plus a degrees. Next, we want to find equations of trigonometric functions from given graphs, right? So let's look at the graph here. So we want to find the values of the a and the b, right? What would that a represent? A would represent the amplitude, and this b would represent the shift, the vertical shift up or down. So let's see there. To find the amplitude, I need to know the range. I can see the range is from -1 to 3, right? And therefore the amplitude would be half the distance between the minimum and maximum, which is 1 plus 3, it's 4 over 2, which is 2. Therefore a is equal to 2. Now to calculate that b value, I just substitute. So that will be 2 sine, and I just get the value 0. Let's see what it will be. So 2 sine 0 plus b, sine of 0 is 0, so that falls away. Therefore b is equal to 1. Okay, so this graph has moved 1 unit up. Let's take another one. There I've got a cos b x plus b. So first of all, to find the a value, I need to find the range. The range is between -4 and 2. So that distance is 6. Therefore, the amplitude is 6 over 2. 4 plus 2 over 2, which is 3. Therefore, the a is 3. Now substitute the 3. Therefore, I get 3 cos of 0. Always take 0 plus b. Cos of 0 is 1. 3 times 1 is 3. They bring the 3 over. Therefore, b is equal to -1. Let's look at these, and now we want to find a and b, but the a and b comes from two graphs. It's a cos of x and sine of x plus b. This a is the amplitude, and this b is a vertical shift. For the amplitude, let's find the range is between -2 and 2. Therefore, the amplitude will be 2 plus 2 over 2, which is 2. So therefore, a is 2. Then the next one, vertical shift. So if I look at that vertical shift there, you see this is the graph. That graph were to start at 0, it moved 2 down. So therefore the b is equal to -2. Okay. Let's look at the problem involving tangent. Again, here we want to find values a and b. So let's look at there, a and b. This a is not the amplitude, right? That's stretching the tangent curve. And this b here is a shift, that is a vertical shift, right? So let's look at the vertical shift. Where's the original tangent? The original tangent is at 0, 0. And now it has, as you can see, it has moved 1 down. So it's a vertical shift, 1 down. And if it's a vertical shift, 1 down, that implies the b is equal to 1. Okay, let's look at the a now. Now that I know the b value, I can substitute. So I can have a tangent, but I need a point. And this point here is a very convenient point, 45 and 1. So if I substitute 45 and 1 in there, and I put the b value, I now get a tangent of 45 minus 1 for the b equal to that 1. And if I do that little bit of arithmetic, tangent of 45, easy. That's 1. So a negative 1, transpose the negative 1. That's correct. A is equal to 2. Let's consider another example. We have to find the values of a and b. But here we can see this is sine of ax. So this a affects the period. And this is cos of bx, that b affects the period of the cosine. Okay. So to find the period of the f graph, if we look at the f graph, the period there is 120. See, there's a sine pattern there, 120. Even there's 120. So the period is 120. So to find the a value, it's the standard period of 360 divided by 120. So that gives me 3. Therefore, a is equal to 3, right? Similarly here, if I look at the G graph, there's the G graph, right? That period is, you see, from there to there, that is 120, and from there to there, or you can just see 60, 60, 60, 60, 4 60s is 240, so the period is 240. So the B value is 360 divided by 240, which gives me 1,5, or 3/2. Let's look at another one here. Here we have A and B, and you can see these A's and B's are shifts. That's x plus A, so we have to see which way is it shifted, and that's x plus B, right? You see A, we don't know whether A is a positive value or a negative value, or whether B is a positive or a negative value. So let's see. If I look at, we have to follow the y-intercepts of the sine graph, and there's the y-intercept of the sine graph, originally at 0, 0. So this graph there, you see it has moved 30 degrees, you see. So this yellow one, from the origin 0, 0, it moved 30 degrees. It moved to the right, 30 degrees to the right, which means that A value has to be negative 30. Okay. If I look at the cosine graph again, the cosine graph's original y-intercept would have been at 1. There's at 1. Now it moved this way. You see, this way is to the left. And how many degrees? 90 degrees to the left. So therefore, it will be 90 degrees to the left. And what does 90 degrees to the left mean? To the left means plus, so it's plus 90. Next, we're going to look at sketching graphs of trigonometric functions, and here using your table mode on your calculator. Now let's see how we can use the table mode on your calculator for assisting you to sketch trigonometric functions. Okay. Now let's take the example here. Let's say you have to sketch the function defined by fx equal to sine of x, and you have the domain from negative 90 to 270. Now I'm using this particular Casio calculator, but there's beside differences with other calculators, but very minor. First of all, when your calculator switch on, you press mode, and then you get this selection here. On some calculators, you will find you have to look for table. In this case, table is 7, right? In other calculators, it might be 3 or 4, so you just have to look for table, right? Because we're going to use the table mode. Then you enter 7. You can see there you enter 7. And if you enter 7, you'll see this appearing on your screen, fx. So now you have to enter sine. So you press on sine. That's where you get sine. Now to get the angle x, you press alpha. See, there's alpha. And there's the x there, right? So alpha x, that gives you the x. And now you have to press the equal, right? If you press equal, you'll now get the word start appearing on your calculator, right? Start, you look at your domain, you see that's negative 90. So my start here is my lower value of my domain, which is negative 90. So there's negative 90. So you enter negative 90, register it, you press the equal, right? And after you press equal, you'll now see end appearing on your calculator. Now what is end? That's the upper limit of your domain, which is 270. So you enter 270. Right? And after you enter 270, you press the equal. Right? You press the equal. And now you get steps. Now the steps here, if you look at this is the function sine of x. That is 1x. So if you have an x, then your steps would be 90. Your default step there would be 90. Right? If you have an x, then your steps would be 90. So you enter 90. There we enter 90 and you press enter equal. And now once you press equal, you'll see a table appearing on your calculator, right? So there I've got the table there, negative 90, then a 0, so it's steps of 90. You can actually scroll down and you can get all the values there, right? Now to make it a little bit more visible, I've just recorded all the values that we get from the calculator. So we started with negative 90 and we end with 270 and we have steps of 90, okay? And if you have the steps of 90, these are the corresponding function values. Now it's just a matter of plotting the points. So you go to your graph and you can see there you want to have your graph labeled, your x-axis from negative 90, there's negative 90, and jumps or steps of 90, there's another 90 and another 90 up to 270. So that's your domain for this particular function. And now you just have to plot. Negative 90 goes with negative 1, 0 goes with 0, and you plot the points and you can join the points. And there we have our sine graph. Right? We're going to look at a few others just so that you can get used to it. Now let's look at another one here. We want to plot here. In this case, it's cos of 2x, not a x, cos of 2x. And again, here I'm choosing the domain negative 90 to 180. It's easy to illustrate with a limited domain. So I've got my calculator. I switch it on. I choose 7 on my calculator. Depends on your mode. So that's 7. And then you get fx. If you get a gx, just skip the gx. fx. So now you enter cos. And now 2x, we have to enter 2 and the x, right? So you enter 2x, there's 2x. You press the equal to save it. Now it asks you to start. And your start here is negative 90, right? Press the equal, enter the negative 90 and the equal. Then you end up with end. So that's 180. You register 180 and you press the equal. Ask you for the steps. Now let's look at the steps there. There you've got 2x. So your steps are changing. Your default steps is 90. So you take 90 divided by 2. And 90 divided by 2 is 45. So my step here is 45. And once you enter your step 45 and you press the equal, a table will be generated. So there's the table. Let me just put down the table. There's your table. And let's just list the table here. Here's the table, and then once we plot the points, we can see that negative 90 goes with negative 1, negative 45 goes with 0, 0 goes with 1. You plot, they just have to plot the points, and you can see here I've got steps of 45, 45 and another 45, 45, 45, 45 there. And that is how I can draw cos of 2x. Let's look at another example where to illustrate the use of your calculator. Here I've got fx equal to cos x minus 30, and I'm using a domain of negative 90 to 90. Right, so again there you get your mode, you choose 7. When it comes to your start will be negative 90 and your end will be 90. I'm not showing all the steps of using your calculator. I just want to focus on the step, right? Because that is just your start and your end, that's always given. Now your steps here, you see I've got 1x, but now I've got a negative 30. As we know, this is, I'm shifting it 30. So you use your shift as your step. So my shift is 30, so I make my steps 30. Okay, if you have 45, you make your steps 45 there. So I enter the 30, and then you can, once you enter the 30, you can a table will be generated, and you can see there it jumps off 30. Between 90 and 60 is the 30, and the 30 subtract 30, you know, just jumps off 30. And then I get my graph, and I must just see there, you see these x values are your grid points on your x-axis. Negative 90, negative 60, negative 30, 0, 30, 60, and that. I didn't enter all the values, but those are the grid points there. Negative 60, negative 30, 0, 30, 60, and 90. And you plot the corresponding points. The plotting of points should be not problematic at all. Now, let's take the example where we have tangent. Okay, tangent, always a slight difference there. So I have my calculator. You can see your start will be negative 90, your end will be 180. So we're skipping that step. I only want to focus on the steps. So that's your start, that's your end. So we want to get the steps. Now tangent steps is 45, not 90. So the 1x I'll have 45. 2x I'll have 45 divided by 2. So in other words, I enter the 45, and that's a table to be generated. Now you'll notice in the tangent that you get here undefined or infinity, and this is an indication that you'll have an asymptote there. So by negative 90 there's an asymptote. Let's scroll down. By 90 there's another asymptote, and you see also I have jumps of 45. So this will be how you will have the scale on your horizontal x-axis there. So if I have my graph and I plot the graph, that is what that will be. And you can see the tangent here is at negative 90, and there's an asymptote at negative 90 and another asymptote at 90. There are two asymptotes there, right? So that's how we can use the table mode for. So let's look at the table mode. The start and end values are always given. It's just the steps that you need to determine yourself. So for sine and cosine, the default step value is 90 degrees, right? And the default for tangent is 45. So if I have sine x, cos x, it will be 90. If I have tan x, it will be 45. So let's just see there. So if I have sine x plus a, that's just the x, so the steps will just remain as 90, right? The a doesn't affect it. If I have sine of ax, that affects the angle, so the steps are going to be affected. It's 90 divided by that a value. And if I have a cos of x, that a is the amplitude, it doesn't affect the x. So in other words, my steps remain 90. If I have sine of x plus or minus a, then the steps there will be, in this case, it won't be 90. We'll take the a value, that's shifting, so we'll use the a. We'll come back to that again later. And if I have tangent of ax, for tangent here, my default step is 45, but because I have a, that will be tangent of, the steps here for tangent will be 45 divided by a. Okay. Now I want you to try a few of these examples, so I give you 1 minute to quickly figure out the steps. Shouldn't take you longer. So let's look at these ones here. Just 1 minute, just pause and then see whether you can get it on your own, and then I will explain it. Okay, so let's start. X plus 60, what will the steps be? Right, 60 is not wrong, but if you use 60 you will miss some points, right? Because if I go with 60, the next one is 120, so I will miss a point. So the best, instead of 60, don't use 60 for the step, rather use 30, because you can get 30 and 30 will make a 60. So do not use 60, rather use 30. Cos of 3x, my default 90 degrees will be changed, so it's 90 degrees divided by 3, so that is 30 degrees. Here it's just sine of x, so the default remains as 90. Tangent of half x, default 45 divided by a half, and 45 divided by a half is 90. This one here, the default doesn't change because it's just tangent of x. Next, we want to show you some interpretations of graphs of trigonometric functions. Okay, and the first interpretation we're going to do is where you have fx greater or equal to 0, or the other option would be fx less or equal to 0. Okay, so in this case here, we're going to, because I want to find x values, I'll have intervals on the x-axis. Right? Let's say for which values of x, so it will be intervals on the x-axis. So let's look at the two cases there. There I've got fx greater or equal to 0. Remember, there's or equal to 0. And the other one here, I'm just going to take fx less than. There's no equal there. So when it's greater or equal to 0, I have to look at the x-intercepts, right? And I have to see where's my curve above. And because I have an equal, it can also be on the x-axis. In this case here, less than 0 mean below the x-axis. But because I don't have an equal, I don't have the option of being on it there. So let's look at this graph there. You see there's the graph from negative 90 to 360. When it's above, right? So I want to look at the portion above the x-axis. This is this portion here, the portion above. Let's just clearly make it more visible for you. You can see the above portion I've got in the solid line, and the below is in the dotted line. So that is the above, that's the greater or equal. And so it will be greater or equal from 0 to 180. But because I said equal, that 360 is also, fx is also equal there. So I've got the answer from 0 to 180. There's an interval, and I also have a 360 there, right? So this answer will be that interval, but also include the 360. Let's look at the other one here. Let's take the same graph, and I want to look at below, but I don't have an equal sign there. So let's just highlight it. So the below portion I've got in the solid line. Right? This is what I want. So you can see there are two intervals, from 90 to 0 and from 180 to 360. Because it's not equal, you see there's an open. It's open there and open. But this 90 is not the x-intercept. So my answer there will be from 90 to 0. Can you see this is included because that isn't the x-intercept. That's not equal there, not equal there, not equal there. So I can write it down from negative 90 to 0 with a square bracket because it's equal, and where it's not equal I put the rounded bracket or rounded braces there. So that's from 180 to 360. Now let's look at the interpretation of fx minus gx equal to a, right? Now again here we want x values because fx and gx we want x values. Now this a here, first of all we look at the case where a is 0, and then we look at the case where a is some positive integral value, right? You can also take negative values, but you're going to concentrate on the positive values at this stage here. So if I take fx minus gx equal to 0, now what does this actually mean? Fx minus gx equal to 0 is the same as, that's correct, it's the same as fx equal to gx. And what do we find if we have fx equal to gx? That's correct, that we need to find there's your two graphs, we have to find the points of intersection. Do you see the points of intersection? That's correct, there's one. And what's the corresponding x value? Negative 30. There's another one, right? So x equal to negative 30 is one answer. That's the intersection at x equal to negative 30. There's another one, and I get the corresponding value. That is at 0. So x is equal to 0. There's another one. Are those? No, there's another one right at the end there. Right? Don't just look at it carefully. And the corresponding value there is 180. So there are 3 points of intersection here at negative 30, at 0, and at 180. Now let's consider the case here where the a is not 0. Right? Again, we're going to find x values, no intervals. In this case here, if we look at the graph, and I look at fx minus gx equal to 1. What is this fx minus gx equal to 1? That is the distance between the graphs, right? The distance between the f and the g must be 1. So the distance between f and g must be equal to 1. So I have to look where is the distance between the yellow and the green 1. Do you see the place there? That's correct. If I look at that distance there, that distance exactly 1. And what's the value there? The value is at negative 90, right? There is another one maybe somewhere here, but we won't be able to find it exactly. You can't guess and estimate exactly. At negative 90, there's exactly a 1. Let's take another one. Here I want the distance between the two, 3. To see the distance, 3. That's a 1. It's less than 1, less than 1, less than 1. And it's very small. Then it's smaller and gets bigger and bigger and bigger and bigger and bigger and bigger until I get to that place where it is exactly there. And what is the corresponding x value? That's correct. The corresponding x value there is at 90, right? So in this case here, you don't have intervals. You have exact places where the distance between the two would be equal to that distance there of 1, okay? Or the difference between the two must be equal to that value. Now let's look at this here where we want to interpret fx greater or equal to gx, and also we could even have fx less or equal to gx. There we've got a f curve in yellow and the green and the g curve in green. So easy referencing there. Here we're going to need intervals on the x-axis. Now it's very simple, similar to the other. Because I've got the fx equal to gx, I need the points of intersection, right? So I definitely need the points of intersection. And you see the points of intersection? That's correct. We have to isolate your points of intersection that you're going to have there, right? There's the 3 points of intersection. So I'll need the corresponding x values, negative 30, 0, and 180, okay? But what does fx greater or equal to gx mean? What do I have to look for here? I can say it's fx greater or equal to gx. That means it's the fx must be the greater, understand, to be above, and the equal means it can only be on. It's where it intersect as well. Where is it above and where does it intersect? So just to help you here, let's just highlight by making this a little bit bolder. Can you see there the f graph is above the green? And the next portion here between that intersection and that intersection, between the negative 30 and the 0, there the f is below, and I've indicated with a dotted line there. Then again, from the 0 to 180, it is above. So let's get the interval. So, and because I've got the equal, it's from between negative 90 and negative 30, and then nothing there, and then between 0 and 180. Let's write it in interval notation. Negative 90 to negative 30, or 0 to 180, right? And because it's equal, you've got the square brackets that we're using there. Now let's look at another type of relationship here. Here we've got the product of the two, fx times gx greater or equal to 0, or fx times gx less or equal to 0. We're going to look at each of these two cases here. Let's just take the graphs again there. There's my f graph in yellow and my g graph in green. And again there, because of the inequalities, we're going to have intervals as our result here. Now, what do we mean by fx times gx greater than 0? What does greater than 0 actually mean? That's right, greater than 0 means positive. Now, how do I get a positive? What times what is positive? A positive times a positive. Or, that's right, a negative times a negative. So I've got two options. I must see where the one is positive and the other one is positive, where the one is above and the other one is above. Then I also look at the other situation where the one is negative and the other one is negative, or the one is below and the other one is also below. So I've got two options there. We're going to look at the x-intercepts there, right? Because fx positive, I have to look at the x-intercept. So I have to look at the negative 90, the 0, the 90, the 180, and the 270. So there's the interval, there's the interval, there's the interval, there's the interval. Okay, so I can have both of them above the x-axis, or I can have both of them below, right? Now, to assist you here, I'm just going to draw the portions bold and some of them in bold. So you can see there, that is positive with a negative. That's a positive with a positive. So I want both positive. So I want this one, and negative with negative, right? So actually the ones that is not applicable here are the ones in dotted lines there, because that's a positive times a negative. So that's it. So I can see there, it's between 0 and 90 and between 90 and 180. Because I don't have the equal, I've excluded the 0, excluded the 90, and excluded the 180. So let's look at our intervals. There's our interval there, 0 to 90, and the other one, 90 to 180. Don't make a mistake and write it from 0 to 180, because the 90 here is not defined for 90, it's excluded. So we'll have to have 0 to 90 and 90 to 180. There's no equal, so I use the round brackets here. Now let's look at another one here. In this case, I'm going to take fx times, and I'm going to use less than 0. Okay. Now what is less than 0? Less than 0 means negative. So it's a positive times a negative, or a negative times a positive. So that, what does that mean? That's correct. It means one needs to be a below and the other one above. One above and the other one below. So there are two options. So if I follow there, the G is above and the F is below. So that will be, so if I just do that, can you see there? So the dotted ones are the ones where it doesn't apply. That's a positive times a negative, so that's the correct one. But here it was positive times positive. Here it is positive times negative. So that is where my intervals are. Can you see? Between negative 90 and 0, and there's another one from 180 to 270. And because I don't have the equal, I exclude the endpoints. I don't use a square bracket, I use a round bracket. I'm going to show you how you can apply what we've just done in the previous sections. Let's look at the first example. We've got two functions f and g, and they're defined by fx equal to 2 cos x and gx equal to sine of 2x. And we've got a domain between negative 90 and 270. First of all, we want to draw the graphs, and you know, for the drawing, you're going to use your calculator. Then we want the range and the period and the general solution, and then we've got some interpretations that we have there. So let's look at the first one. So to draw this graph, you go to your calculator. It should be quite easy using your mode, and you can plot the cosine graph. There's the cosine graph, right? And you can plot the sine graph, and there's your sine graph, right? We're not going to go through the calculator use. So drawing graphs, you just use your table mode, and you can see here I need steps of 90, and here I need steps of 45. You can see there I've got 45 for the G function there. Now write down the range, so it should not be difficult. If I look at the f, there's the f, the range, I use my amplitude, and that's correct, there's the range. You can see there, even from the graph you can see it, it's from negative 2 to 2. Next we want to determine the period. Now there's a new function here, h, and they define the h. The h is defined in terms of the g. If I look at my g graph, what is the g function's period? The g function 2x, the g function's period is 180. But now I want to have g of 4x, so there's a change again. So that was 180, and I divided by 4. So then the period for that h will be 180 divided by 4 is 45 degrees. Okay. Let's do the next question. Now we want to find the general solution. Normally equations can always be linked to your two graphs, because we want to find points of intersection. So I have 2 cos x equal to sine 2x, and sine 2x I can use an identity. That's 2 sine x cos x. I suggest you go to my other video to see how the different methods of solving trigonometric equations. And then I can transpose everything, and I'm going to use the zero product. Take out a common factor, 2 cos x and 1 minus sine x. And then the zero product, cos of x can be 0. And there's the 2. From my graph, I know cos is 0 at 90 and at 270. Because I want general solution, I add k times the period 360 plus k times the period 360. The other option is sine x is 1, and sine x is 1 from my graph is 90 degrees plus, and actually this one is the same as that one, right? So I only have these two, so that's my general solution. Okay, now, and we can even see here from the graph, you see it intersected at negative 90 and at 90 and at 270. Those were the answer I got from my general solution. Now we're going to use our graph to answer this. Fx greater than 0, what do I have to look for? That's correct, the f graph, which is the one in yellow, greater than 0, above. Can you see where is it above? That's correct, it's above between 90 and 270. Because negative 90 and 90, sorry, between negative 90 and 90. And because it's equal, I include the point negative 90 and 90. So there's the answer, negative 90 and 90. It's much easier writing it in interval notation. Let's look at the next one. Fx less than g, what does that mean? I need to use the intersection points. And you see there's the intersection points. Negative 90, 90 and 270. Less than, where's the yellow below the g? Right, not above, there's the yellow below. And it's below there between 90 and 270. Because I don't have an equal, you see that's excluded. So I've got it excluded, so it's 90 up to 270. And let's look at the last one, the product. And this product must be negative or as well as equal to 0. So if I look at the product there, so one above and one below, so that will be that piece. Can you see there? That's positive times negative and positive times negative. It's very similar to the one we had earlier. So there's it between negative 90 and 0 and between 180 and 270. Now let's look at the second example. In this example here, the graph is given. You don't have to draw the graph. So we have fx equal to tan x plus a and gx equal to b sine x. I suggest you highlight this if you have it in an examination. And you can see the domain is from negative 180 to 180. Write down, so this shouldn't be that difficult to find the a and the b values. Then we want the minimum, and then we have a transformation, and then we have some interpretations there. Now let's consider the solution. There I've got the graph. The f graph is in purple and the g graph is in yellow for easy reference, and I've got the domain from negative 180 to 180. So let's say the first question there is we want to determine the values of a and b. You can see a here is part of the tangent, and what does that plus a mean? That's correct, it's a horizontal shift. And now we have to determine whether it was shifted to the left or to the right and how much it has shifted. Where does tangent normally start? Tangent normally starts at the origin, right? So there's 0 and 0. And you can see there it moved from 0 and it moved to that point. And what is that point? There's 0 and there's 90, and it's exactly in the middle. So that will be 45 degrees, right? And which way did that move? This moved to the right. And if it moved to the right, it will the a value will be, that's correct, it will be negative 45 because it's moving to the right. Now to look at the b value, this is the amplitude. So I have to identify the amplitude, and you see the amplitude, the maximum value is 3 and the minimum value is negative 3. So the amplitude is 3. There the amplitude is 3. Therefore the b value here is just equal to 3. Let's look at the second one here. We want to determine the minimum value of h, but there's no h here. Yes, but they define the h in terms of g. So I have to transform the g's minimum value. What is the minimum value for g? If I look at g, that's the yellow one, and what is the minimum value? the lowest value there is -3. So what must I do with that -3? So I must take -3 and then I subtract 1 from it. Easy, that's -4. Describe the transformation. So in words, I must look at my transformation. I look at the gx, which is b sine x. So, but in this case, though, I want identify the function transformation of g, and I've got a new function here. Let's say that is kx, and that is -gx plus 2. So negative gx, what does negative gx tell you? Negative gx, what's happened to the function? That's correct, it was reflected in the x-axis. And what does the plus 2 mean? That's a vertical shift, up or down. Plus indicates up, so it's shifted 2 units up. And there we've got the solution for A, B, and C. Now let's look at some interpretations of the two graphs. So there's my two curves there. The tangent is there in purple, and the G is my sine graph. Fx less than 0, so the F is my tangent curve. What is less than 0? Below but not on. You see, it's not an equal there. So where is it below? Can you see there? And here I only want it from 0 to 180, so I'm not looking on the negative x values. So it says, say, from 0 to 180. So between 0 and 180, you can see there's the tangent graph below. And between 135 and 180, the tangent graph is below there. And because I don't have an equal, I exclude the endpoints there. Now the next one, fx minus gx equal to 2. What do we have to look for? Where's the distance between the two graphs 2? Now if you look for that, can you see it? That's correct. There's only one place. There's it exactly equal to 2. Right? That's a place where I know it's exactly equal. There's also a 2 somewhere. There's also a 2 somewhere else here. Right? But I want that one is definite. So it's at 90 degrees. Right? So that will be x equal to 90. The next question, the product greater or equal, where's the product positive? So that, what does positive mean? Both needs to be positive or both needs to be negative. And remember, I only want to look from 0 to 180. So if you follow that piece, can you see there? From that angle 45, that one is positive and the tangent also positive. But between 0 and 45, the sine is positive, but the tangent is negative. From 135 to 180, the sine is positive, and so this is the interval there. But because I have an equal, I can include that 45. But 135 is an asymptote, so I have to exclude the asymptote value there. Now we're coming to the most important part of the video, and this is the exercise worksheet. It's for you now to start practicing. I've taken some questions from external Department of Basic Education question papers and slightly adapted. This one is from November 2014. You are given the graph of one of the functions and you have to draw the other, and then there are some applications there, right? Interpretations. This one is from June 2015. Here both graphs are given, so you don't have to draw. There you have to find the numerical values. You have to find the period, and then you have to find general. So you are given the general solution, and you just have to find the points of intersection based on the graph. And then here we want to find a new equation, and there we have some interpretations. There, the one graph greater and the product less than 0. Let's look at the third one. Here we've got a tangent and a sine graph. Again, some numerical values. Find the period, find the maximum value, and then here we have an interpretation. And then I have one more question, November 2018. This is just the tangent, right? You have to find the general solution of that tangent graph, right? In terms of A being t and 2, then you have to draw the graph, and then you have to do an interpretation where's fx greater or equal to 2 using your graph, and here you have to describe a transformation. Look at the given one and look at the new one there. Okay. I hope you enjoyed this video and also benefited from the video. that you now have a better understanding of trigonometric functions. Please also view other videos on grade 12 CAPS Mathematics on our YouTube channel, GMMDC Nelson Mandela University. And please subscribe to our channel, and if you have any comments, please send your comments and like. Right? Solutions to all exercises of all the videos have also been uploaded and available on the site.